Hello, in this short video we are going to solve the following challenging problem on the topic of binomial expansion. If in the expansion of the expression that you see on the display now, L sub 1 is the minimum of the term independent of x when pi over 8 is less than or equal to theta less than or equal to pi over 4, and L sub 2 is the minimum of the term independent of x when theta belongs to the interval from pi over 16 to pi over 8, then L sub 2 over L sub 1 is equal to. Pause the video at this point and give it a try to see which one of the following given options is the correct answer to the problem. Okay, now let us solve the problem. So this binomial to power 16 is given to us, and we know that there is a term which is independent of x in the expansion of this binomial. And it is given in the problem that if you limit theta within this interval, the minimum of that term independent of x is L sub 1. And if you limit theta within this interval, the minimum of the term independent of x is L sub 2. And the problem is asking you to calculate it L sub 2 to L sub 1. Yes, is that right? Yes, L sub 2 over L sub 1. Okay, so how can I solve the problem? So let me write a formula for the binomial expansion. So if a and b are real numbers and n is any natural number, then this can be written as this sum. K goes from 0 up to this number n choose k, and then the first term to the power n minus the counter of your sigma times the second term b to the power of the counter of the sigma. And of course, you can immediately see that this expression is playing the role of A, this expression is playing the role of B, and 16 is playing the role of N. So this expression becomes equal to sigma. K goes from 0 to 16. 16 choose K. And this expression, which is x divided by cosine theta to power 16 minus K, multiplied by b, which is this expression, sine theta to the power of k. Okay? So let me simplify this a little bit, because here cosine theta plays the role of the coefficient. 1 over sine theta plays the role of the coefficient. I have to raise them to these powers and put them here. That will be the overall term, constant term for me. So this goes from 0 to 16. This is 1 over cosine theta to the power of that, so I can write it as 1 over cosine theta to the power of 16 minus k. And this one will be 1 over sine theta to power k. And then I have 16 choose k. And here x to this power is left, multiplied by 1 over x to power k is left. Okay? Okay, so let us see what we can do now. Here I can simplify this expression a little bit. So here x to power 16 minus k is divided by x to power k, so it becomes x to power 16 minus k, which is 16 minus 2k. But because I am discussing about term independent of x, so I want to see which term is independent of x, so I have to put the exponents equal to 0. So 16 minus 2k equals to 0. This gives me that k is 8. Okay, so the term independent of x becomes equal to what? K is 8. If I put 8 here, it becomes 1 over cosine to the power of 8. Cosine theta to power 8. This also becomes sine theta to power 8. So if you don't mind, let me write it here. And then this becomes 16 choose 8. Okay? So this is the term independent of x. That is a generic argument, okay? But now we want to talk about the minimum of this term in two different intervals. One that interval, the other that interval. Okay. But if I want to find the minimum of that, hopefully this combination will look familiar to you, yes? Because sine cosine appears with the same power, 8. So I multiply the numerator and denominator by 2 to power 8 because my goal is to use the double angle formula for sine. So 2 to power 8, so this becomes equal to 2 power 8, and then in the denominator 2 to power 8 cosine theta to power 8 sine theta to power 8 can be written as 2 sine theta cosine theta to power 8, and then I have that number 16 choose 8. So I will keep it for the time being, but this is 2 to power 8 is 256. So let me write 256, and this one can be written as sine 2 theta to power 8. So sine 2 theta to power 8, and then 16 over 8. So this is the term independent of x in the compact form. Okay, but now I want to talk about the minimum of this expression under two conditions. So let us, for the time being, concentrate on the first interval. Okay. So if you don't mind, let me call this term I for independent. Okay. So if I limit myself within this interval, theta is between pi over 16 and what? Pi over 8. So if that is the case, let us see where will sine theta, what sine 2 theta be. So I multiply both every side by 2, so it becomes pi over 8 less than or equal to 2 theta less than or equal to pi over 4. Is that right? Oh, I consider this one first. No matter. So then I will consider this one. This is 2 theta. So now 2 theta is somewhere between pi over 8 up to pi over 4. So if I go to the unit circle, pi over 4 is here, and pi over 8 is half of this angle. Okay? So the angle 2 theta is going from here to here. And my goal is to find the minimum of this expression. If I want to find the minimum of this expression, these are constant numbers, so I have to maximize my denominator. So it means that the maximum value of sine 2 theta occurs when I have the highest point, because sine is related to the y coordinate. So it means that if I want to find the maximum of sine 2 theta, I have to pick up this point whose y coordinate is the highest y coordinate among the points of the arc here. Yes? So this means that to the maximum of sine 2 theta within that interval is the sine of 45 degrees, or pi over 4, which is 1 over square root of 2. So if I want to find the maximum of this to power 8, I have to raise this to power 8. So this becomes 1 over 2 to power 4, which is 60. So this is the maximum value of sine to the power of 8 to theta within the second interval. Okay? In the first interval, if theta is somewhere between pi over 8 and pi over 4, again, I will do the same. I multiply everything by 2. So pi over 4 is less than or equal to 2 theta, less than or equal to pi over 2. But this time, 2 theta is from pi over 4 to pi over 2. So now I am on this part of the arc. Again, I want to minimize this, so I have to maximize the denominator, but the maximum is 1. Yes, because that is the highest point. Yes? So this means that the maximum of sine 2 theta to power 8 is just simply 1. Because 1 to power 8 is just 1. Okay, so now if I ask you what is L1, do you remember? L1 is the minimum of this expression under this condition. which becomes exactly this number, 256, 16, choose 8. And what is L2? L2 is the minimum of the same expression under this condition, which occurs when I have this maximum for psi. So instead of this expression, I put 1 over 16, but 1 over 16, 16 will go up, it will be this number. But the problem asks me about what? I hope that you can see it. L2 over L1. So the question mark is L2 over L1. But if I divide L2 over L1, we are done. Because this one and that one are gone, this one and that one are gone, so I get 16. So the correct answer to the problem should be 16. So if we go back here, we see that option D is the correct answer. I hope that you found the video helpful. Until the next video, be safe and goodbye. Thank you.